In this video on factoring in algebra, we're going to learn how to factor trinomials with a leading coefficient equal to 1. Before we begin factoring, let's take a look at what happens when we multiply two linear binomials where each of the leading coefficients is equal to 1. So a general example with no actual numbers would be x plus a times x plus b. Now many of us that have done this in the past know a process called FOIL or double distribution. I have a box that visually shows you what happens when we multiply all of the combinations together for those of us that are more visual learners than audio learners. So we see on the side I have x plus a, and on the top I have x plus b. So when we multiply each combination, x times x gives me x squared, x times a gives me ax, b times x gives me bx, and a times b gives me ab. So we've done that a million times with all kinds of different examples, hopefully at this point. In order to really understand factoring, it's important to know the other direction, which is multiplication. So let's take a look at this a little bit further in detail so we maybe can notice some patterns in what's going on in this combination of products. The nice thing about displaying this set of products this way is your like terms are usually on the diagonal from the bottom left to the top right. And that's the case here. We have ax plus bx. If we had some actual numbers in here, you would see you could combine those terms together because they have a like variable to the same power. You'll also notice that that same combination of ab is being multiplied together in the last box. So if we look at this horizontally, we can see we have ax plus bx combining like terms using the distributive property. A plus b is our middle coefficient, and then our constant at the end without a variable x is a times b. So that pattern is going to come into play, and it's something that we're going to use as we go forward looking at our factoring process. Now if this seems to be a bit of alphabet soup, let's take a look at an example with some actual numbers in here. So in this example I've replaced the a and the b with a 4 and a 6. So you can use the box method that I just went through, or if you're comfortable with FOIL or double distribution, you can use that as well. But the box visually shows us that x multiplied by x gives me x squared, x multiplied by 4 gives me 4x, x multiplied by 6 gives me 6x, and then 4 multiplied by 6 gives me 24. So anytime we have a multiplication problem like this, we're going to have 4 products, and this is what it looks like. If you've done a million of these, you'll realize that there are like terms. Again, the nice visual part of the box is that your like terms are typically going to be on the diagonal here. So 4x plus 6x is going to be our combination of like terms. That gives me 10x. So we notice here that our middle coefficient I have in red is the combination of the sum of 4 and 6, 4 plus 6. And our constant at the end here, 24, is the combination of the product of 4 and 6. Again, that pattern is going to be very, very important as we factor these polynomials with a leading coefficient of 1. So now that we've taken a look back at multiplication, the main purpose of this video is to factor trinomials. Now we're going to focus on trinomials with a leading coefficient equal to 1 in these cases. So in front of the x squared, there's always going to be just a 1 there. There are some situations that we will look at in the future where we have a leading coefficient other than 1, but that will be for another video, so be on the lookout for that when it's added to my channel. So in this case we have x squared plus 13x plus 30 as our first example. We know that this is going to factor into some situation where we have x plus a times x plus b. Using the visual aid of the box is very helpful again. We know x squared is going to break down into x times x in the multiplication process. And then we know we have a times b as our last term in this case, which is 30. So our two values we're looking for are going to multiply together to give us 30. And then we know the other two terms that we originally had were added together to give us 13x. So those same two values, a and b, are going to add together to give you 13. So let's think about a procedure that's going to help us figure out two numbers that not only multiply together to give you 30, but they're going to also add together to give you 13. So our factored form of our original problem here is x plus 3 times x plus 10. If you're not sure that you did that correct, you can throw the values of 3 and 10 back into your FOIL or your box problem, and you can see here visually again x times x is obviously x squared, x times 3 is 3x, x times 10 is 10x, and then 3 times 10 is 30. If you add 3x and 10x, that gives us back to the 13x. So This process is very easy to work backwards and forwards with the multiplication process and the factoring process. Let's take a look at a second example here and then we'll close out this video. So I've got x squared plus 7x minus 30. This time I need to find two values that add together to give me 7 and multiply together to give me negative 30. Now again, it's easier to figure out the pairs that multiply together to give me 30. I can worry about the signs later on. I don't have to put all the combinations of addition and subtraction signs inside the factor pairs because that becomes a long list when you have bigger values later on. So I look at all the combinations, and the only two that can add together to give me 7 are 3 and 10. But I need to make one of those negative so that I get a negative 30 when I multiply and add together to give me 7. So the negative has to go with a 3, so I can do negative 3 and positive 10 to add together to give me 7 and multiply together to give me negative 30. So my factored form of this original problem, x squared plus 7x minus 30, would be based on these two numbers, 3 and 10, and it would be x plus 10 and x minus 3. Now in this case, the signs are very important. The negative 3 has to go, or the negative has to go with the 3, and the positive has to go with the 10. You can write whichever one you want first. You can do x minus 3 times x plus 10 because of the commutative property, but you have to have the negative sign with the appropriate value in order to get this correct. If you're ever not sure when you go through this process, you can always work backwards using the box that I've shown you throughout this video or your typical FOIL or double distribution method. Once you've done a million of these, you can see you can do them in your head very quickly. So that's it. Once you've connected this process to the opposite operation, which is multiplication, it becomes very easy to work with. There are some more difficult cases that we'll go through in future videos when we have leading coefficients and more terms, but we'll leave that for another time. Thanks so much for watching. Please feel free to visit my channel for more videos on algebra and other topics in mathematics. Thanks again.